Here is an explanation for the answer to final exam, question number 21, in Physics Demystified, 2nd edition. If you have the printed book, please refer to page 516. This particular question has to do with the theory of special relativity. We're talking about a spaceship here that's moving so fast that it causes a time dilation factor of 4.00. Now that is a really fast spaceship. A spaceship that moves that fast, you can calculate with the formulas backwards if you want, is a pretty good fraction of the speed of light. Well over 90% of the speed of light. If the ship is not moving, we would see it look like this. With a time dilation factor of 4.00, it's going to look squashed along the axis of its motion by a factor of 4. It's only going to be 1/4 as long as it would look if it was not moving, assuming, of course, that we could actually see the spaceship go by at a speed like that. But in our imaginations, we can do anything. And that's what relativity is all about. Mind experiments like this. Imagine that we ride in a spaceship that travels so fast that the time dilation factor equals 4.00. If we encounter a stationary meteoroid whose rest mass equals 16 grams, here's the rock, 16.0 grams. That's not very heavy, just a little rock. 16.0 grams. How much mass will it have in effect when it strikes the hull of our vessel? Well, if this thing is stationary, that is, not moving, relative, say, to the Earth, it's going to be moving at the same speed as this ship is moving with respect to the Earth. In other words, it's going to be as if this meteoroid is almost moving at the speed of light. The relative speed between the meteoroid and the ship is going to be the same as the relative speed between the ship and the meteoroid. So when that thing hits, it's going to experience the same relativistic effects as we would get with a time dilation factor of 4.00. It's going to appear as it comes at us and about to hit us. If we could see it, it would look squished, squashed. It almost look like a disc or a pellet. If it was a spherical meteoroid, it would look like like an aspirin tablet or something. Coming at us, the mass increases in the same proportion as the time dilation factor when we have a situation like that. So instead of 16.0 grams, this thing is in effect going to have, when it hits us, 4 times that, 64.0 grams. That is choice B.